Hi everyone, in this video I'm going to show you how to calculate a volume of revolution by using disks. So this is problem number 1, let's jump right into it. Here we go, find the volume of the solid obtained by rotating the region bounded by the given curves about the specified line. The very first thing you want to do here is graph each of the curves that are given here. So I'm going to draw an XY plane. Alright, first up is y equals x cubed. It's going to look like this here. So this here is y equals x cubed. Next up is y equals x. That's just going to be a straight line that goes through the origin. That'll do, I guess. Y equals x. And now x greater than or equal to 0 means that we consider only the part that is to the right of the y-axis. So basically everything to the right here. So our area of interest is going to be everything bounded within these two curves here. We ignore these curves on the left side here. This here is what's called the area of interest. That's what we're going to rotate about the specified line here, which is the x-axis. So I'm going to it's not necessary to draw the reflection here, but I'm just going to do it to illustrate what this is. So I'm going to draw a reflection of the area of interest about the x-axis. So we're using disks in order to calculate the volume of this revolution here. So I'm going to draw a circle that goes through the top part of the curve and the bottom here. So this circle is going to look like this. Next up, I'm going to draw a circle that goes through the lower bounding curve. So this part right here. So this here is what's called a washer. It's basically a disk that has a hole in it, this magenta hole in it. The volume of revolution is going to be V equals integral of ax dx. Ax is the area of this washer here. The area is going to be the area of this outer disk. That's going to be pi times the radius, which is the height. That's the, I'm just going to call it x here. And I'm going to subtract the area of this smaller disk within. So it's going to be pi times, what is the radius of this? That's going to be the height, which is, the height of the red curve is x cubed. And radius squared, and then dx. Now the question is, what do we use for the limits of integration here? So to answer that, we have to look at our area of interest. The lowest possible value of x is going to be, this is the smallest value of x here of our area of interest, so it's going to be 0, and the highest value of x is going to be where these where the orange and the red curves intersect. So to find this x value, we have to set these equations equal to each other and solve for the x value. So off to the side here, I'm going to say x cubed equals x. So I'm going to bring x to the left side, so we have x cubed minus x equals 0. I'm going to factor x now, so to get x times x squared minus 1 equals 0. And now this is a difference of squares pattern. I can factor it further. This is x times x plus 1 times x minus 1 equals 0. So by the zero product property, x equals -1, 0, 1. And since x has to be greater than or equal to 0, I'm going to choose 1 here. That's going to be this number right here. So 0 and 1 are my limits of integration here. And now it's just a matter of calculating. So I'm going to factor the pi out and bring it out in front of the integral. So this is pi times the integral from 0 to 1. This is going to be x squared, and now minus x cubed squared is going to be x to the 6th dx. Okay, so this is pi, and now to integrate x squared, I simply bump up the power by 1 to get x cubed, and I divide by that same number. And I'm going to do the same for the next term. I bump up the power by 1, and I divide by that same number. And I evaluate it from 0 to 1. And now I just plug in the limits of integration here. So this is going to be equal to pi times 1 cubed over 3 minus 1 to the 7th over 7th. And now I do the negative of this for the 0 part. So minus 0 cubed over 3, and then plus 0 to the 7th over 7. And these terms are 0, so we don't worry about those. And 1 cubed is just 1. 1 to the 7th is just 1. So this is equal to pi times 1/3 minus 1/7. And if I just combine the fractions here, so this is going to be 7 minus 3 over 3 times 7, which is 21. So this is 4 over 21. So our volume here is going to be 4 pi over 21. All right, thanks for watching. Stay tuned for the next problem.